Hey everyone, so this is going to be another A-frame tutorial video on physics and collisions. And the reason we're doing a part two is because, to my discovery, the open leap or the leap motion controller that we'll be using, which is this thing right here, um, in order to enable the physics for that and objects in the scene, you can only use the A-frame physics system alone. If you try to use an extension of that, like the ammo backend or the ammo physics engine backend, then it doesn't work. It just breaks. So we're gonna do another video talking about the A-frame physics system alone and basically how the syntax is different and how to achieve physics in A-frame. All right, so of course, just like usual, we're gonna look at some starter code when you're doing a project with physics in it. The first thing we're going to notice is that we need to use an older version of A-frame if we're going to use A-frame physics system alone. Unfortunately, when A-frame was updated to the latest version, at the time of making this video, the latest version is 1.2.0. They deprecated code, I think, with the 3.js file, which handles I think it handles geometry and different volumes and shapes. And unfortunately, that causes the A-frame physics system code to break. And it's just really bad. If you try to do it with 1.2, some objects fall, some don't, some collide, some will. It's pretty bad. So, and it's not a big deal. Sometimes you do have to go to an older version. And in our case, we're really lucky because 1.2 doesn't add too much. In fact, 1.1, you could almost think of it as 1.2, but without the deprecation of the code that causes things to break. So, all right. And then this code probably looks familiar if you saw the first physics and collisions video. This is the A-frame physics system. And obviously you're going to notice that that's the last script we're adding. We're not going to be adding the ammo physics backend because while it does add extra functionality, unfortunately, this doesn't work with the A-frame, or it doesn't work with the open leap or the leap motion controller code. So we have to scratch that idea and just use the A-frame physics system. But that's okay because the A-frame physics system still provides a lot in terms of the physics and collisions. Now, obviously you need your A scene element, but if you want to add the debug true property, you can go for it. I think I would recommend it because it helps you to catch physics errors or errors in your code. I think the debug set to true also shows you like the shape of the colliders for each of the objects as well. So you can use it for that, but you can add the debug true if you want or not, but I would recommend it. All right, so the ammo code syntax and the A-frame physics system code syntax alone, they're going to be a little bit different, but mostly there's a lot of similarities. So if we're just using A-frame physics system alone, we have things like a static body and a dynamic body. And the one thing to note right off the bat is there's no such thing as a kinematic body anymore. Static bodies are stationary or animated. And if you remember from the first video, static bodies were the ones that are unaffected by forces. So other objects can collide with them, but they won't interact at all. They'll just stay where they are. And the kinematic bodies in the ammo physics backend, those were basically a special type of static body that were animated. But in this case, static body covers all of those. So static body can be stationary or animated. And yeah, so then the last thing that's left is the dynamic body. So if you have gravity set, you can also set the mass for these as well. They're affected by all forces. They're affected by gravity, so they'll fall. And yeah, that's basically about it for that. All right. So for the dynamic body, you can set things like the mass, which is pretty cool. So it'll maybe have more, let's see, kinetic energy when it hits an object, right? Because you have the kinetic energy equaling 1/2 times mass and then the velocity squared. So if you increase the mass here and then it's heading towards an object, it's going to have more of an impact or more kinetic energy. So that's a really cool thing about it. And then the other thing too, you can set the shape as well for the collider. So if it's a, and you'll notice too that for these examples, I'm leaving it as a entity. But usually what you're going to use is a primitive object like an A box or an A sphere. And yeah, so the shape is a sphere, just for the collider. All right, so there is a special type of a property called constraints in the A-frame physics system. And essentially what a constraint is, well, a constraint is basically a way to attach two physics bodies together. There's, I think, like a hinge. Yeah, so there's a hinge type. I think there's also like a fixed distance type. So if the cube and if one cube and another cube are constrained by the fixed distance type, if the one cube moves over this way by 2 units, then this cube will also move over by 2 units. They'll just keep a fixed distance from each other. But in this example, what I did was I set the type to hinge. Now, the first thing about constraints is you have to set something called an ID. So it's basically just giving these entities or these objects a name so that they can be referred to by another object. And you'll notice that in the constraint attribute in our other object, we have the target set to anchor. Now, the important thing is you need the hashtag symbol in front of that ID of the other object in order to get it to work. And then, of course, the other property you can set is the type, just like hinge. All right, so springs are a special type of constraint, and they have their own attributes. So instead of setting constraint and setting like type spring, spring is its own kind of constraint. So you don't use the constraint attribute, use the spring attribute. And a similar thing between constraint and spring is that you set an ID and then you have your target. So if your ID is start, then your target is hashtag start to connect the two. And for spring, you can set properties like damping and stiffness as well. All right, so the last thing we can do, hopefully to make this a little bit more clear about how this looks in an actual scene, we're going to have an actual example where we're using physics. All right. Here, there we go. So this is the scene using A-frame physics system alone. And what you'll notice is I put a few more properties in the A scene or in the physics attribute in A scene. So I still left debug to true, but I actually set the gravity to 1/6 of what Earth's gravity is. So I set it to the gravity of the moon, which is negative 1.63. Gravity by default is negative 9.8, or basically Earth's gravity. And then you can also set friction too for all the objects in the scene. So that's one property you can set. There's a huge number of other properties that you can set for the system configuration of the A scene physics. Those are on the GitHub repository documentation though. So if you want to figure out, if you want to try more of those out, definitely check it out. So the next thing is I added an A plane. So I added a plane to the scene, and you can think of this as like the ground of the scene. It's really good practice to do this because then if you have dynamic objects that are affected by gravity, they won't just fall from the scene and then disappear forever. So the one thing I do when I have an A-frame physics system scene is I always set a floor or a ground with A plane, and I obviously set it static body, right? Because I don't want it to move. And then I position it in a way that it's like just in front of the screen so you can see it. And then I set a good height and width. You'll notice that the units in A-frame are actually meters. So this plane is actually a decent size. It's 10 meters by 10 meters. Now, I added two dynamic bodies to the scene. I added an A box, and that's really about it for the box. It's placed a little bit above the plane that I created, or that floor, and it has the dynamic body. So when I start this scene, if I look at it fast enough when it starts, I'll see the box fall onto the plane. And let's see. Yes, so the second object that I added was another dynamic body, and I added a sphere. But this is an example where I actually set the mass to 4. I think by default, the mass is usually 1. So I set it to 4 in this case, just to show that you can change the mass of an object. But yeah, so that's about it. The extra documentation that I would recommend is right here. So this is the resources and documentation page of the slides. And of course, this will be available to you. But the first bullet point is the actual GitHub repository of this A-frame physics system that you'll use. And if you go to the README file, it will tell you a lot about all the different properties you can set for the physics in the A-frame scene. And then this was just another website that I looked at, especially while I was making this video and these slides. It's just more examples to get you more used to using physics in A-frame. So yeah, so that's about it. If you have any questions or concerns, feel free to reach out to me. But yeah, thanks for watching.